Today, I'm going to present the paper titled The Income Effects of Cooperative Membership, a Heterogeneous Analysis. This is the outline of today's presentation. So agricultural cooperatives play a crucial role in reducing rural poverty, improving food security, and generating income in developing and transition countries. Several studies have examined the impacts of cooperative membership or particular services provided by the cooperatives on farm income. In general, these studies found that cooperative membership has a positive and significant impact on farm income. These studies have assumed that the income impacts of cooperative membership are homogeneous. That is to say, cooperative members with lower income and higher income have equally benefited from agricultural cooperatives. However, the impacts of cooperative membership on farm performance, such as farm income, may be uneven. This is because that farmers are usually endowed with different self-related characteristics, such as age, gender, education, innate abilities, motivations, and production resources. From a policy perspective, policymakers are more interested in understanding the influence of a development program such as agricultural cooperatives on the distribution of income, outcome variables such as farm income. However, no previous studies have explored the heterogeneous impacts of cooperative membership. Therefore, the primary objective of this study is to estimate the heterogeneous impacts of cooperative membership on farm income. This study aims to contribute to the literature from two aspects. Firstly, we employ an innovative two-stage predictor substitution model combined with an unconditional quantitative regression model to conduct the data analysis. Secondly, we use unique data collected from blind farmers. This is different from previous studies that have focused on green crops such as wheat and maize. So to estimate the heterogeneous effects of cooperative membership, two approaches can be potentially employed. This includes conditional quantitative regression model and the unconditional quantitative regression model. Between them, the estimate of the effect of a treatment variable on outcome variable in the conditional quantitative regression model is depending on the selection of the control variables. That is to say, when we add or delete the number of the control variables, the estimated effect of the treatment variable might be different. In comparison, the unconditional quantitative regression model can overcome the drawback associated with the conditional quantitative regression model. By estimating the unconditional quantitative regression model, the effect of the treatment variable on outcome variable will not change when we add or delete the number of control variables. So in the presence of endogenous treatment variable, instrumental variable quantitative regression model can be applied. However, the IVQR model relies on conditional quantitative regression model estimation. That is to say, when we add or remove the number of control variables, the estimated effect of the endogenous treatment variable might be different. Therefore, in this study, we employ a two-stage predictor substitution model combined with an unconditional quantitative regression model to facilitate the empirical analysis. So in the first stage of this approach, a probability model can be applied to estimate farmers' decisions to join agricultural cooperative. This equation can be expressed by equation 1. So in equation 1, Ci star represents the probabilities of a farmer's decision to join an agricultural cooperative. Zi is a vector of control variables. Ivi is a vector of instrumental variables. Alpha I and beta I are parameters to be estimated, and epsilon I is an error term. So in the second stage of this approach, we estimate a farm income equation using the recentered influence function. So for example, here Q tau denotes the farm income Yi at quantile I. So for farm income at quantile tau, we can use equation 2 to facilitate the estimation. As we mentioned previously, cooperative membership in the income equation might be heterogeneous. Therefore, we use the predicted cooperative membership after estimating the equation 1 to replace the original value of the cooperative membership in the income equation. That is to say, Ci prime is a predicted cooperative membership variable. The predicted variable addresses the heterogeneity issues. So the data used in this study are collected from China in January 2019. A multi-stage sampling procedure was used to conduct the farm household survey. So the data are mainly collected from 3 provinces from China. This includes Hainan, Yunnan, and the Guangdong provinces. We select these 3 provinces because they are major banana producing areas. In total, together, the 3 provinces produced around 2/3 of the total banana output in China. So the final sample includes 626 households. This includes 138 cooperative members and 488 non-members. So table 1 presents the variable definitions and descriptive statistics. So here, farm income refers to the gross revenue minus production costs of banana production. It shows that the mean farm income in our sample is around 4,000 yuan per mu. Yuan is a Chinese currency, and mu is a unit to measure land size in China. So 1 hectare equals to 15 mu. So the membership variable is a treatment variable in this study. Our sample shows that around 22% of the households had membership in agriculture cooperatives. We also select other variables such as age, gender, education, and other variables as control variables in our models. Table 2 presents the main differences in characteristics between cooperative members and non-members. In general, the information presented in this table shows that cooperative members and the non-members are systematically different in terms of observed characteristics such as age, gender, education, household size, farm size, and soil quality and locations. The finding here tries to show that banana farmers self-select themselves to be cooperative members and non-members. So the heterogeneity issue of the cooperative membership variable should not be ignored in empirical analysis. Table 2 also shows that cooperative members obtain higher income than their non-member counterparts. However, this descriptive information is not conclusive because it does not control for confounding factors that may also affect farmers' decision to join agriculture cooperatives and farm income. The figure 1 shows the farm income distributions at the selected quantiles. So the figure shows that farm income is remarkably different between cooperative members and non-members and across the selected quantiles. The information found here potentially suggests that cooperative membership has a heterogeneous impact on farm income. Therefore, we conduct the empirical analysis to find the rigorous evidence. So table 4 presents the results estimated for the determinants of cooperative membership, which is estimated by a probability model. The results show that farmers' decisions to join agricultural cooperatives is influenced by social, economic, and household level characteristics. For example, the coefficient of age is negative and statistically significant, suggesting that old farmers are less likely to join agricultural cooperatives. This is probably because that old farmers are usually in unfavorable conditions of health. Therefore, they have no incentive to be cooperative members. Farm size variable has a positive and significant effect, suggesting that farmers with a large farm size are more likely to join agricultural cooperatives. This is because large farm size can enable farmers to achieve the economics of scale. And finally, neighbor membership is also positive and statistically significant. This would suggest that farmers are more likely to be cooperative members if their neighbors are cooperative members. This is due to the peer effect. In this study, neighbor membership is selected as an identifying instrumental variable. So table 5 shows the results of the impact of cooperative membership on farm income, which is estimated using the unconditional quantile regression model. So, as we mentioned earlier, membership is a predictive variable. It is predicted after estimating the first stage estimation. The predicted variable controls for the heterogeneity issue of the cooperative membership. The results show that, in general, cooperative membership has a positive and statistically significant impact on farm income. And also, we show that with increasing the quantiles, the impacts of cooperative membership on farm income are monotonically increasing. The findings suggest that farmers with higher farm income are more likely to benefit more from agricultural cooperatives than their counterparts with lower farm income. Okay, so this is the main concluding remarks from this study. We show that farmers' decision to join agricultural cooperatives is mainly determined by their age, gender, farm size, and asset ownership. And the farmers at the higher income quantiles tend to benefit more from agricultural cooperatives than those at the lower income quantiles. And the farm income is affected by farmer education, farm size, soil quality of land, and asset ownership. So based on the analysis, we suggest that agriculture cooperatives should pay more attention to their lower income members in service provision, as low income are very likely to be economically marginalized. Okay, thank you. That's all for the presentation.